All right, so now that we've learned a whole bunch about trig ratios in triangles, and we've learned how to take angles out of triangles now and put them on a coordinate plane, today we're going to kind of combine that together and talk about how do you take just any old angle and figure out its trig ratios by putting it on the coordinate plane. Okay, so we're going to find trig ratios using a point that's on the terminal side of an angle. Okay, and you'll see what I mean about that in just a second. All right, so here's the basic steps that we are going to follow. So the first thing that we're going to do is we are going to draw the angle in standard position. Okay, that's what we've been practicing. So draw it in standard position. That's pretty easy. Second thing that we're going to do is we are going to make a right triangle. So make a right triangle with the closest side of the x-axis. And that's important. It needs to be the x-axis, not the y-axis. So the x-axis, that's this one, right? So not the up and down one, the sideways one. All right, and once you've made that triangle, then you're going to use your right triangle. I'm going to abbreviate that with a picture of a triangle to find all of your different trig ratios. Okay, so we're going to draw it, make a triangle, and then we'll just use the triangle as we've always been doing. Okay, so let's take a look at this one. So negative 4, 3 is a point on the terminal side of the angle, and we're going to find our 6 trig ratios and then figure out what the actual angle is. So let's take a look at this. Here's a little baby coordinate plane. So the point negative 4, 3. Okay, so negative 4, 3 means I'd go to the left 4 and I'd go up 3, right? So it's about here. There's my point. So what this is telling me is it's telling me that that point is on the terminal side of my angle. So if I actually go on here and draw my angle, I know my initial side is going to be over here because it always is. And it's just saying that the terminal side goes through that point, right? The side actually goes on forever. That's why we stick lines there, right? Sides of angles go on forever. So it doesn't like necessarily end at that point, but it goes through it. Okay, so that kind of tells me where my angle goes. Okay, so from here, we can then calculate our trig ratios. So what I'm going to do is I am now going to make a right triangle. I've got my angle drawn, and I'm going to use that to create a right triangle. And I'm going to do that by going from my point. I'm going to make a straight line that goes to the closest side of the x-axis. So that's this one. So this would be the closer side of the x-axis. This is a farther away side from that point, right? So I'm just going to drop this line straight down so it's perpendicular and makes a right angle. Okay, so that's the triangle that we're going to use. So I'm just going to over here, I'm going to kind of zoom in on that. So I'm just going to redraw this triangle over here so that we can see it a little bit better. So this is that same triangle that we have in here. Now let's think about what we know about this triangle. Well, because of the way that I plotted that point, right? Negative 4, 3, we went to the left 4, right? So this side here, that's like negative 4 long. And then we went up 3, right? So that's like positive 3. Okay, so we've got this information. Okay, and then this angle down here, the one at the origin, that is something called a reference angle. Okay, so it's this angle right here, right? That is my reference angle. And the cool thing about a reference angle is that you can treat that angle when you're finding your trig just like you would any other angle that I gave you. So like if I told you that the angle was 35 degrees, right, and you find all your trig ratios off of it, you can treat this angle exactly the same way. However big that angle is, you can use that to calculate the rest of your trig ratios. Okay, so it's really cool. So that is our reference angles. That's this guy right here. And that's what we're going to use to figure out, okay, well, where's my opposite side, my adjacent side, and all that, right? So this side from that reference angle would be the opposite side. This is the adjacent side. Here's my hypotenuse. Sorry, I sneezed. Okay, so to find our 6 trig ratios, we know we need all 3 sides. So I'm going to have to figure out my missing side. So I'm going to find my missing side, which is the hypotenuse. So in my Pythagorean theorem, which of course we're going to use, I need that to be c. So I'm going to do 3 squared plus negative 4 squared equals c squared. So that's 9. Negative 4 squared, negative times a negative is a positive. So that's still positive 16. So that's 25. And then when I square root both sides, c is 5. Cool. So now I know that this side length is 5. And that makes it pretty easy for me to find my trig ratios. So to find all my 6 trig ratios now, right? Sine, so katoa, sine is opposite over hypotenuse. So the sine is the opposite over the hypotenuse, 3/5. Cosine, so katoa. So the cosine is adjacent over hypotenuse, katoa, CAH. So that's -4 over 5. That is why it's important that you include this negative here. So if you were thinking to yourself earlier, but in a triangle, you can't have a negative side length, we include that negative because our cosine is negative. And by just throwing that negative on there, it's going to make sure that you don't have to really worry so much about the different positives and negatives. All right, and then my last one is tangent. So tangent is opposite over adjacent. So 3 over -4, which is the same as -3/4. You can put the negative in the front or in the top or the bottom. Okay, and then once we've got that, cosecant is the flip of sine, so that's 5/3. Secant is the flip of cosine, so that's going to be -5/4. See how I just kept that negative in the top? Okay. And then cotangent is going to be -4/3. Voila, 6 trig ratios. Okay, so really this isn't much different than what we've done before. Okay, so you're just drawing this triangle and then you're using those sides to figure out your different trig ratios. Okay, and then the last thing they asked us is to find the measure of the angle. Well, now that we've got all these lovely trig ratios, you can take your pick of which one you want to use and just use the arc whatever, right? So I'll go with sine. I'm going to use the arc sine of 3/5, and that's going to tell me what my angle is. Okay, so that angle is about 36.9 degrees. Okay, if I use the arc cosine of -4/5, okay, that's going to give me it's going to give me 143 degrees. So let's talk about that in just a second. Okay, so the arc cosine of -4/5, that gave me 143.1. And let's try arc tangent. So arc tangent of -3/4 gives me -36. Okay, so you're thinking to yourself, the heck, Miss King, how do I know what angle this thing is, right? We've got 3 different answers here. Well, that's okay. We can figure this out because look at what our picture looks like, okay? Is this going to be a 36-degree angle? No, obviously not. 36-degree angle would be over here, right? It's going to be a 143-degree angle. You can tell just by looking at it, right? It's more than 90, but less than 180. So I know that this guy in the middle is going to be the answer. Okay, well then you're thinking to yourself, but Miss King, how does that help me, right? Why are these other two not the answer and how would I tell? Well, what is this 36.9? That's what my reference angle is. Okay, remember we use this angle right here? That's our reference angle. If you take that 36.9, oops, sorry, you can't see. Take that 36.9 and we add it to the 143.1, right? That adds up to 180. So what this angle we got with our sine is it's telling you what this angle here is. So to actually answer the question of what is our actual angle, you're going to have to do a little bit of thinking to figure it out. It's not always necessarily going to be that you can just grab the cosine and have that work. Okay. And then with tangent is kind of giving you the weird one. It's that same angle, but it's going kind of the opposite direction. All right. So I know it's weird. You'll figure it out. You just got to put a little bit of brain power into it. All right, so then this last thing I want to talk about is trig ratios. How do your trig ratios change between your quadrants? Okay, so let's just think about this for a second. So this is that same point, 4, 3, but it's like this one over here is +4, +3. This is -4, +3. This is -4, -3. This is 4, -3. Okay, so all of these guys are different. All right, so what I want to kind of look at here is that if you think about the coordinates of this point, this is a positive, right? This point is a -positive. This point down here is a negative, negative, and this point over here is a positive, negative, right? And you know that. You've been doing this on your coordinate planes for forever. Okay, so how is that going to change things? Okay, well, in this quadrant, what this is going to tell you is that you're going to get a positive number for both your sine and your cosine. Okay, so your sine is going to be positive and your cosine is going to be positive. And that should be pretty instinctive because when you think about if we set up our triangle, right, they'd both be positives. So when you simplify, it's going to stay a positive, right? All right, this next quadrant over here, okay, what this is going to tell me is that my sine is going to be positive and my cosine is going to be negative. Okay, and that's like the example we just did, and we saw that happen, right? Because the way that these guys are going to work out in this quadrant, this side will be negative, this side will be positive, just like it was. So since the y coordinate is positive, that ties in with my sine, so that's going to have to be positive. And since the x coordinate is negative, that's tying in with my cosine. It's my adjacent side, right? So that's going to end up negative. Okay, this guy down here where they're both negative, what that's going to tell me is that my sine and my cosine are both going to be negative. So my sine is going to be negative and my cosine is going to be negative. Okay, and again, think about why. Because in our triangle, this side length would be negative and then this would also be negative, right? So when I divide it by my hypotenuse, I'll get a negative and a negative for my cosine and my sine. And then this last one down here, this is going to tell me that my sine will be negative and my cosine will be positive. Okay, and how do I know that? Well, I know because when I draw my triangle, right, there's my angle, make my triangle with the closer side of the x-axis. This is going to be my reference angle, right? So my opposite side over here, that's going to be negative. It's going down. So opposite divided by my positive hypotenuse, that's going to give me a negative answer. But my adjacent side, that's positive. Okay? So that's what my reference triangle would look like, right? My reference triangle up here, here's the closer side of the x-axis. My reference triangle over here, here's the closer side of the x-axis. Okay? And then my reference triangle over here, here's the closer side of the x-axis. So notice that I'm never making my triangle this way. Don't make your triangle with the y-axis. It's always with the x-axis. Okay, so you could kind of memorize this if you want to, but as long as you draw a picture and you pay attention to your signs, you're going to be all set and you're not going to have to worry about it.